Hello, grade 12. So today we are going to look into mid-latitude cyclones. This is one of the low pressure systems, okay, that we're going to be studying. So let's get into it and see. Now, for a start, we're going to look into air masses that are needed for mid-latitude cyclones. So you need cold air and warm air. So for cold air, you must know that cold air is heavy, okay? Cold air is heavy and also it's dense, okay, and it's also dry. Okay, so cold air is heavy, dense, and dry. Then warm air is actually what is it? It's light. Okay, it's light and less dense. Okay, and also it has some moisture. Okay, so that's what we need to know about what is it? The two types of air. But now, since we say it's heavy, so what happens to it? It sinks. Okay, so what is it? Cold air sinks. If these two air masses meet, the cold air sinks, so it actually lifts up the warm air. And what does warm air does? It rises because it is light. Okay, so when it rises, what happens to it? It cools down. Okay, cools and condense. Okay, condense, forming what is it? Clouds and later precipitation. Okay, so which is rainfall. Okay, okay, so that's what we need to know about these two air masses. So this type of clouds that are formed there, you can see that there are tall clouds which we are going to be talking about, which we call cumulonimbus clouds. Okay, so what we know, cold air, when cold air meets warm air, cold air is lifted up. So cold air, warm air is lifted up, cold air sinks, then warm air rises. And when it rises, it cools down and form clouds. Let's move on to the next what is the slide, where we're looking at weather station. So in most cases, you will see that you will see this actually weather station model, and in this circle here is actually representing cloud cover. Then in terms of the precipitation, you will see the precipitation here, and we've got different types of precipitation here. We have got rain, drizzle, shower, and everything. And this is what we actually seeing when you are looking at cyclones. Okay, so thunderstorms are actually associated with cyclones. So here we also see that there is wind speed. This actually the arrow here, and these bars, if the bar is outside, it's representing 10 knots because wind speed is measured in knots. And if the bar is inside, only one bar is actually 5 knots. And when you have it like this, it's actually 25 because we're saying 10, 10, and the 5. Okay, so then the wind direction where the stick is pointing, where this stick is pointing, is actually our northeast actually wind. Okay, so let's move on to the next slide. Now, let's understand low pressure systems and high pressure systems, since we'll be dealing with this in this climate and weather topic. Now, when you look at low pressure system are represented with an L inside here, and you find that the pressure at the center is lower than the surrounding pressure. So you can see that here is 1000, 1200, goes on like that. So it's increasing from the center. Then when it comes to high pressure systems, it's actually decreasing from the center. So we're saying the pressure at the center there is actually It's higher than the actual surrounding air pressure. But what we need to also understand that low pressure systems are unstable. So they are unstable, meaning to say these are the one that brings lightning, flooding, thunderstorms. So that's where we are saying they are unstable. Okay, they are unstable. But when you look at high pressure system, the high pressure systems are stable systems. Now let's also look into how does the air move in the on low pressure system and high pressure systems. Now on low pressure systems, air converge at the bottom, okay, on the ground. So, and when it converge, it rises and diverge at the top. So here, this is what we see: air converge at the bottom, then diverge at the top. So that's what we need to know when you're looking at low pressure systems. So they are associated with rising air. Okay, so associated with rising air, and when it looks to high pressure system, they are associated with subsiding air or sinking air. Okay, so the air that is going down, so you find that, and it's cold air there that is actually what is it, sinking. So in this case here, we are saying they are associated with subsiding air. Okay, so they converge at the top and diverge at the bottom. So that's how the air circulate in high pressure and low pressure systems. So we're going to be dealing with low pressure tropical cyclones and mid-latitude cyclones, and also high pressure system, which are your anticyclones, South Atlantic, South Indian, and Kalahari high pressure. Okay, but today we are only looking at mid-latitude cyclone. Now we're going to look into different aspects of mid-latitude cyclones. Let's get into detail and see where do these actually form. So you need polar easterlies. Polar easterlies. Remember, we said for our mid-latitude cyclones, we need warm air and cold air. So this is our source of our cold air. So our cold air is coming from the polar region, and it's actually easterly, in the direction of from east to west. And what we have here, we have got the westerlies in the what is it, in the what is it, from the equator. There you can see from the center we have got the warm air, actually, which you call the warm westerlies. Okay, so warm what called westerlies. So these are warm, this is our source of our warm air, because remember, we need cold air and warm air to meet. So where do they form? They are formed, they are called the mid-latitude cyclones because they form what called 30 degrees to 60 what called degrees going north and also going south. Okay, so 30 to 60, that's where they are forming. And as you can see here, this is Africa here, and this is where they affect what called the southern part, which is South Africa, but not the entire country, but it affects part of the western side. Okay, Western Cape. And let's look at this into also detail showing the planet. You can see that mid-latitude cyclones occurs in families. So you can see that there's a group of mid-latitude cyclones here forming. So this is how they appear. Okay, so they are formed in the from 30 to 60 in what called going north and going south. Okay, from the equator. Now let's move on to the next one, which the conditions that we need for mid-latitude cyclone to form. What do we need? We need cold air. So cold air, number one, is cold air that is needed. Then we also need what called warm air. And where is the cold air coming from? We are saying from the polar region. So polar easterlies, and these are warm what called westerly winds. Okay, then the differences in the temperature cause the imbalance, and also the difference in direction will also cause the circulation that we will later have. But we're not talking of developments here. We just need the two air masses to be of cold, one to be cold, one to be warm, and they need to have different temperatures, and they need to be actually going different directions. Those are the conditions that are needed. But now, another thing that we also need to add there is that they are prominent, meaning to say they are strong, they affect South Africa in winter. Okay, what are the characteristics? We need a low pressure in the center. So we need the L. So they're always having an L in the center, and that shows that it's a low pressure system. Then another thing, there's clockwise movement of air in the what we call mid or in the southern hemisphere. So there is clockwise and anti-clockwise on the northern hemisphere. So the air circulation is clockwise in the southern hemisphere and anti-clockwise on the northern hemisphere. Now, presence of cold front, we'll talk about that. The cold front is just leading cold air. We need the cold sector. We also need the presence of warm air, warm front. Also, these are actually shown here. We can just have a look here. So we need the cold front, we need the warm front, we need the cold sector. This is our cold sector. We also need the warm sector there, and there is actually another cold air there. So that's what we call that's what is how the mid-lat cyclones look. So then let's move on to the other one. We need the isobar pattern to be oval. So then movement, it has to be from west to east, west to east. So these are major points that you must remember. Then affect western side of the continents in the mid latitude, and diameter of the mid cyclones are from 1.5 to 3,000. So you can see that they are actually huge cells. Okay, they travel at a speed of 50 to 60 kilometers per hour, and the lifespan also it's between 4 to 14 days. But these things you can actually be given. So if you are given, maybe let's say it started on this date, ended on this date, you now know that what was the lifespan for that particular cyclone. So it's not something that you need to worry about. It's not something that you need actually to remember. Now, the usual occur in families, like what you've seen there, what called on top. They can also see there how they are appearing. They actually in groups. Okay, they actually occur in families. If you look here, they actually are occurring in families. So this is 1, 2, 3. They are all cyclones. Okay, so they form all year. So mid-lat cyclones occur all year round, but they affect South Africa in winter because of movement of what call our ITCZ to the north. Okay, so the intertropical convergence zone and also our high pressure systems, they move north in winter, and that movement actually brings the mid-lat cyclones closer to South Africa. Now, stages of development. Now, we need initial stage, development stage, mature stage, and occluded stage. And lastly, it has to be the dissipating stage, which I have added there. Now, what happens on the initial stage? Initial stage, we are saying two air masses are moving in opposite direction, parallel to each other. And now there is a polar, they are not mixing it, because remember, they can't mix because they are of different, they've got different density, like I said, they're also different temperature and also different what you call humidity. So in this case here, we are saying they are moving parallel to each other and they are not mixing. And the boundary line is, we call that polar front. So we refer that as polar front. Okay, polar front. Okay, that's that's the line here separating the cold air and warm air. So they do not mix, and now friction starts between these air masses, and we go to the developing stage. Now on the developing stage, a wave develops in the polar front, and the small masses of warm air extends in the cold air and rises. So we start to see cold air following starting to lift warm air up. And in that case, now we are starting to see the circulation, because remember, in moving the warm air, we start to see some circulation, as you can see there. Then the rising air causes a low pressure in the center. So once warm air starts to rise, we know what happens now. It cools down, forming what you call cumulonimbus clouds. And we move on now to the mature stage, where we are saying the low pressure intensifies. So we are more warm air is being lifted up now, and we can now see that there is a circulation, and the circulation is clockwise on the southern hemisphere and anti-clockwise on the northern hemisphere. So it moves into the westerly wind belt. So here, this is another thing that you must know: why your mid-lat cyclones move from west to east. They actually occur on the westerly wind belt. Westerly wind belt. So the westerly wind belt is the one that cause the movement of what call cyclones to move from west to east. So they will ask you what actually what's behind the direction of mid-lat cyclones. So you must know that they are actually in the westerly wind belt. So a well-developed cold and warm sector develops. So when A mature stage is indicated by a V structure. A V structure showing you the cold front. So the cold, showing you the cold front, okay? A clear cold front and clear what called warm front. That's what you must actually see on the mature stage. So we see the V what called shape, and that shows us that that's the mature stage. Now, cold dense air moves faster and forces the light humid less dense air into the warm sector to rise. So remember what we spoke about in the beginning, cold air lifts warm air. Now the cold sector becomes larger and than the warm sector as cold moves and lifts the warm air. So the whole thing, the whole point behind this thing is that cold air is lifting warm air. That's the goal here. The cold air is lifting warm air. What happens on the cool stage now? On the stage, we are saying the warm sector continues to narrow and cold front overtakes warm front, and cold air wedges in under warm air. The warm air then becomes isolated from the ground. Now, what is happening here is that we have an occlusion that is happening there, because how do we see the occlusion? We see by alternative cold and warm, cold and warm. That shows us that this is an occluded stage. So it shows that the cold air catches up with warm air. And we are now seeing that there is a mixture there, mixture of warm and cold air that is actually happening there. And you can only see that through the alternate cold and warm, fronts. Okay. Now, then the last stage here is the dissipating stage, which in this case now we are saying all the warm air is displaced on the ground. And now the mid-latitude cyclone, in this case, since there is no more warm air being raised, it means that there won't be clouds being formed and there won't be rain, in that case. So it means that this is our dissipating stage and the cyclone will die once all the warm air is actually lifted up. Now, let's move on to the occlusion. Let's understand the occlusion stage here. We have two types of occlusion stage. We have got cold front occlusion and warm front occlusion. Now, when you have got cold front occlusion, it means that the cold air is the one on the surface. So the cold air is on the surface, and what you see, if you are to check it on the synoptic, you find that you have something like this. Okay, you have something like this here. So what we have got the cold front. So the arrow for cold front there, it will be actually on the center. So if we are to have our low pressure there, the cold front is the one, the last, showing that it is on the on the ground. Okay, so that's that's how your cold front occlusion is indicated. What about warm front occlusion? Warm front occlusion, here we see that on the center, on the low pressure cell, we find that what is the last part there is actually the warm front. The sign there for the warm front is on the center, and followed by the cold front, the warm front. So here we can see that the sign for the warm front is on the center. The sign for the cold front is actually on the center. That shows that it's a cold front occlusion. But remember, the warm air is still being lifted up, and actually rain is also occurring, but it's no longer strong rains, because the clouds that we are now having is nimbostratus clouds, which are low clouds, and they bring light rainfall, not heavy rainfall, compared to cumulonimbus clouds. Now let's also understand the cross section of mid-latitude cyclones. Okay, so as you can see here, we have got cumulus clouds here. So these are your cumulus clouds. Okay, then here we have got cumulonimbus clouds. So okay, so these are cumulonimbus clouds, and what we experience, what is happening on the cold front. So on the cold front, these are the conditions that you will see. Okay, on the cold front, these are the conditions that you will see. We see that the wind changes direction from west to southwest. Okay, so it's southwest direction. Then we also have strong winds there is a decrease in temperature. There is also humidity is actually high during precipitation, because remember, humidity is actually referring to amount of moisture in the air, and we are saying it's high during the precipitation, during rain. Okay, during rainfall. Then cumulonimbus clouds form, as you can see. So the cold front is associated with the cumulonimbus clouds, because here raising steeply. So we are saying warm air here is rapidly raised, what call, or rapid is lifted up by cold air. So we find that more warm air is being lifted up and forming these cumulonimbus clouds. We also experience heavy rainfall and poor visibility on the cold front. Okay, but when you look at the warm sector there, this is our warm sector. This is the warm sector. Now, on the warm sector there, what you see that is you find that you see clouds like stratus clouds. Okay, stratus clouds, and what is it? These cirrus clouds. These are tall, what call clouds that you see on top there. Then you also have autostratus clouds. So autostratus clouds, that's what you see there. Then here on the warm front, what you see, because warm air here is actually going above, it's going above cold air, because here, remember, it's cold air as well, but it's not cold as the one that we have here. So here is cold air. Then here we have got warm air, which is the warm sector. So we can just indicate here the warm air. That's what we have there. Okay. Then here we've got cold air as well. Okay. Now we are saying here warm air is going above the cold air. It's going above the cold air. And when it's going above cold air, it means that it's going to form these low clouds, which we call the nimbostratus. So warm front is associated with what called nimbostratus clouds. Nimbostratus clouds. So that's what we have. So we have wind direction changing from northwest to west. So this is your warm front. So warm front conditions. This is what is you experience on the warm front sector. Then the temperature also start to decrease, and the nimbostratus clouds and light rain from the nimbostratus, and also visibility start to increase. We have a decrease in air pressure, and also relative humidity is high during precipitation. Then here on the warm sector, there is actually there is a light or no rainfall on the warm sector, and also you find that there is the stratus clouds, and the temperatures are high. So we have got temperatures here. The temperatures are high on the warm sector. Okay, so that's what we are talking about. Now let's move on to the next part there, which is the satellite image. Now on the satellite image, you must understand we have the satellite image and the synoptic chart. So this is satellite image. This is what happens. So here on the southern hemisphere, how do you see the direction of circulation? So if you just follow from outside there and follow it and see that this is a clockwise circulation. So clockwise circulation is actually in the southern hemisphere. So by looking at this can tell us that on which what called hemisphere is it a cyclone occurring? Is it southern or northern? So by just looking at how it's circulating. And what we see also here is that we can see it also by looking at the warm sector. So whenever the warm sector, if the warm sector is on the northern, on the north of the low pressure, it means that it's on the southern hemisphere. And another thing also is that we also see with the warm, this one here, you can show that this is warm front occlusion. That's what we can also see there. We can see that it's warm front occlusion because it's actually warm air on the ground there. As you can see here, this is our, you can see that the difference in the northern hemisphere, the circulation of the air, you can see the circulation of the air is anti-clockwise. Can you see that it's anti-clockwise? And also here you can see that the warm sector there is actually on the south of the low pressure, meaning to say there it's actually in the northern hemisphere. That's what we also need to see. Then we can also tell the wind direction. You can see that the wind direction here in the cloud cover, you can see that the cloud cover here is actually overcast. It's overcast, but here it's actually half, and you can see that the wind direction as well on the northern hemisphere, with where is it going. Now, then let's look at the impacts of middle cyclones. We have positive and negative impacts. So what are the positive impacts? We need rainfall. So winter rainfall determine type of crops that are cultivated. It replenish what call water in the dams, fill the dams when when the cyclones comes, and also snow in mountains replenish again water in the when it melts. Then here negative impacts, snow that falls is dangerous. So you know that those are the snow. If the snow is falling, you know that it can damage people as well. Extreme cold can result in power cuts and disruption of human activities. Then also big winds, we'll talk about this. Big winds formed during winter can cause veiled fire. Then we'll talk about this when we talk of the coastal laws and see how big winds, when you're looking at subtropical anticyclones, we'll also discuss this so that you can understand how big winds are formed. But we need a coastal law, which is the middle cyclone that we're talking about. Then gale force winds are also dangerous to the ships also, and heavy rainfall causes poor visibility and can cause traffic accidents. Then mountain passes over may close if there is snow. Then we have got also impact on the environment. Winter rainfall is necessary for winter crops. That's the advantages. We can grow winter crops and then we have enough water. Then production of winter crops result in food security. Once we have winter rains, it means that we are going also to have crops actually in winter. Then negative impacts now, snow that falls is dangerous to livestock, is also dangerous to crops. Extreme cold damage crops and livestock. Big winds damage vegetation because of dry, warm conditions. Because here, big winds cause veiled fire, and these will damage vegetation. Gale force winds also damage crops, bend crops, and in the fields. Then heavy rain causes floods, which negatively affect crops and livestock. What about the economy? In the economy, production of winter crops benefits the GDP, which is the gross domestic product. Then negative impacts are expensive for farmers to protect crops and livestock. It's very expensive to protect against the cyclones, and floods can damage crops and impact the economy negatively. But what can we do? What can we do? Monitoring the development of meteor cyclones and also giving warnings to people, evacuating people that are in the low-lying areas, and also to protect them, because you know that when there is flood, low-lying areas are being affected mostly. Then keep livestock in barns, so you enclose the livestock, and also stay indoors to protect against cold, wind, and rain. Okay, and also plant winter crops that can resist the cold. In this case, they will have enough water during the winter because of the winter rainfall. Thank you so much, guys. I hope you understand. We'll do some questions for you to understand much better when you are given questions regarding middle cyclones. Okay, until next time, Mr. Stolle here. Bye-bye.